just gonna give you audio. Can you hear me? Hey, I finally see you. It's pretty. Actually, you know what? I ran into the worst problems. Like I came in, I sat down, I was about to join a stream, and the internet in my office crashed on me the very second I sat down. So consider this very good at last minute IT repairs. Yeah. Uh, Actually, Josh, I can barely hear you. I can barely hear you. I'm getting a lot of static on the line. All right. For reference, the current only live streamer is me on my other side doing testing.
Turn that one off. Turn this one on.
That sounds a lot.
Is that better?
Yes.
There we go. Apologize. So I'm going to try and do this all one-handed. So that's even going to be better because I didn't have this one set up at all. But that's okay. That's okay. Live and learn. And so this might be my new setup now from now on. And let's see if I can balance this all out and do this all one-handed. All right. So Brian, sorry, introduce yourself, please.
All
Can
right.
we do that?
Sure. Yeah, I definitely can do that. And if I run into audio problems, please somebody tell me on the line as well.
Yes.
Hi, my name is Brian Lim. I'm the founder of a little company called Dandelions. I don't sell flowers. I do build spaceships. Right now, we're a little startup here in Sydney, Australia. I've been in the space industry for about 12 years and a little bit longer in the startup scene as a whole. So I'm the guy you talk to if you want to go build something.
Nice. Nice. Yeah. And Brian and I have actually done a previous interview together where we talked about his Dandelions device and, yeah, what that actually looks like. So that is actually a very interesting device. And you can go and find it on my YouTube channel, of course. Of course you can. So just to let everyone know, the chat is now open. So if you're new here, please introduce yourself to others. There is also going to be a random merchandise giveaway during the live stream. So if you join us and you ask a question, you could win just by participating. So I just want to remind everyone, first and foremost, everyone here loves the Australian space industry, and therefore, we're saying everything out of love, even though we are, well, I'm being a little bit more critical than some other people, but that's okay. That's my job. That's my job. So I thought I'd just start out with a little bit something interesting and something to get everything going. Basically, India has landed on the moon. Isn't that magnificent? India has finally landed on the moon.
I think that makes them the fourth country to do it.
Yes, fourth country in the world, straight after China. So China was the last one with the Chang'e 4. We'll be talking about the Chang'e 4 a little bit later in this live stream. And the Chang'e 4 is the last one. So that was China's efforts to actually land on the moon. And now India has followed suit, of course, following Russia, who was the first with their lunar lander, and also the US with theirs, and of course, man walking on the moon. So what I'll do is I'll just actually have a little bit of a look at what this touchdown looked like.
जी हाँ, आप अपने स्क्रीन पे देख सकते हैं कि हम लैंडर मॉड्यूल
People are applauding. Let us all wait to hear from the Secretary Department of Space and Chairman ISRO, Shri S. Somnath.
लैंडर मॉड्यूल पूरी तरह से सेफली और सॉफ्टली चंद्रमा के सतह पे लैंड हो चुका है। ये हम लोगों के लिए बहुत ही गर्व की बात है। हिंदी में एक कहावत है कि चंदा मामा दूर के, लेकिन अब हम ये कह सकते हैं कि चंदा मामा अपने घर के।
बहुत ही उम्दा. The hard work of the entire ISRO community has come to fruition.
आदरणीय प्रधानमंत्री जी, नमस्कार. Sir, we have achieved soft landing on the moon. India is on the moon. Sir, I request our Honorable Prime Minister to address us and bless us. Thank you, sir.
मेरे प्यारे परिवारजनों, जब हम अपनी आंखों के सामने ऐसा इतिहास.
So yes, that was a soft touchdown on the moon by the Chan. I'm going to get this wrong. I apologize in advance to everybody who's watching from overseas. The Chandrayaan 3 mission. So the Chandrayaan 3 mission was actually a follow-on mission to the Chandrayaan 2, which was actually to demonstrate the end-to-end capability, safe landing and roving on the lunar surface. It consists of the Vikram lander and rover configuration. The lander payloads include the Chandra's surface thermophysical experiment, CHASTE, to measure the thermal conductivity and temperature, instrument for lunar seismic activity, or ILSA, for measuring the seismic activity around the landing site, the Langmuir probe, LP, to estimate the plasma density and its variations, a passive plasma retroflector array from NASA to accommodate for lunar laser ranging studies. The Vikram rover payload was the alpha particle X-ray spectrometer, APXS, the laser-induced breakdown spectroscope, or LIBS, for deriving the elemental composition of the vicinity of the landing site. And it all happened on the 25th of August. And it can be shown, actually seen. So yeah, so that was amazing achievement, and the reactions from everyone from that was very, very interesting to watch. Brian, what were your thoughts on India landing on the moon?
Absolutely impressed. I mean, let's put it this way: like, India has consistently outdid themselves. They've, sent stuff to Mars, they put stuff on the moon, and they often do it cheaper than a Hollywood movie pretending about it.
I know,
what I mean?
right? It's $75 million, I think, in total, US.
Yeah, you just think, like, I mean, you can say all you want about the business case, like cost differential, salaries, and everything, but some things money can't buy, and that's the skill and dedication required to actually achieve something like this. For our audience, like, the complexity of this is really off the charts. This is not your, hey, I go down to Woolies, buy a few parts, go to Bunnings, buy a couple things, stick it together kind of category, right?
Yeah, correct.
And even for us in the space industry, and when we do the equivalent in the industry, right?
Yep.
We struggle we will struggle to even get it to lunar orbit. Don't even talk about landing, right? So hats off to them, hands down, for the sheer incredibleness of actually pulling it off.
I know, right? It's just absolutely amazing that they did it. I mean, they learned the Chandrayaan from Chandrayaan 2, sorry, which actually didn't make it at all, and then basically they were able to follow up with successful Chandrayaan 3, and now. They've actually shown the rover driving on the moon. They've actually able to successfully and landed on the moon, softly on the moon, safely on the moon, and now I believe it's actually gone into a power down mode. Which was there was also 2 pictures that actually established that actually being on the moon. So I've got a few images of that. I think just give me a sec. There's the actual rover and what it looks like and what's on the rover.
It's then, really quite exciting. Go ahead.
Sorry, I was just going to say that there's it landed not very far from actual crater on the moon, which was actually interesting to see. And so basically on September the 3rd, the rover has since been placed into its sleep mode, and so it will actually, having completed all of its assignments, including moving away from the actual lander itself. Its batteries are all charged and the receiver has been left on in preparation for the impending lunar night. So interestingly enough, the Vikram rover was only ever expected to operate for 1 lunar daylight period, or for 14 Earth days. The onboard electronics have not been designed to withstand the minus 120 degrees Celsius or negative 184 degrees Fahrenheit, and now it now comes down to basically if it can survive. And that's really, really, really interesting, is whether or not it can survive. I mean, the ISRO has proven itself thus far to get quickly and safely to the moon for a fraction of what it costs to do a Hollywood blockbuster, or even not a Hollywood blockbuster, a part of a Hollywood blockbuster, and they've actually successfully been able to do that, which I think is really, really interesting and really, really surprising.
Oh, absolutely. I mean, the hardest part about the space mission is the night, and just trying to last. Well, this is also 14 days of time, that you're in the dark. And, like there's an interesting ways to keep things heated, but that's a lot of energy to keep stuff warm at night when in this scenario. So hats off to them if they pull it off. It doesn't matter if they do or do not. It's just that's the part of that makes it really hard.
Yeah, correct. This is the hard part. They've actually done got in the list of hard parts to do, and one of them is that is actually deorbiting to come down to safely land on the moon. Now the hard part actually comes down to surviving the lunar night, which is, again, as I said, a negative 120 degrees Celsius, or for those people watching overseas in America, a negative 180 degrees, 84 degrees Fahrenheit, which is roughly the same temperature that I believe unleaded petrol will freeze from memory. So I think it freezes at that sort of level. At least it gets very slushy. So yeah, it's very, very interesting. It's very, very, it's surprising, and I'm happy for them. I'm so excited for them. And I watched the video myself and I was just like, I was excited. And I've been excited several times by the whole process. It's just amazing. And for the fraction of the cost. So, I just, I just lose words. It's just so fabulous. It's just amazing that, India finally could do it. And I mean, it's literally showing the rest of the world what they're capable of.
Absolutely. To put into perspective, the moon is where we have measured the coldest place in the solar system. So I'm sure their rover's not parked there, but it's going to experience it's so cold in some of these spots on the moon, right? That if you had a glass of water, it would freeze in under a second.
Yeah. It is incredible. The conditions. I was going to say atmospheric. It has no atmosphere. It's a vacuum. Landing at the lunar South Pole has certainly proven, their capability, and to do it quite successfully, and to get scientific information from that mission, and just again, as I said, it just stuns me. But and this is the thing, is like, what's next for the for ISRO? What is the next biggest thing? So the next biggest thing out of ISRO, which is there was a mission launched to monitor the sun that happened very recently. But believe it or not, mate, there's the I'm going to get it wrong again. I apologize to everyone. The Ganganyaan. That's their human space flight mission. English is my worst. Is my enemy. They're going to do human space flight. Believe it or not.
Yeah, it makes, to be honest, I actually wonder why they haven't done it sooner.
Yeah.
You know, like they got to Mars and everything. They could have started the human space flight mission way earlier. But I also know the standard, and I'm like, yeah, I get you would push that as the last thing you worry about, right?
Yep.
I'm not too sure how I would feel about Bollywood from space.
No, I don't care. Bring it on. Bring it on. Look. It's been a very a two horse race until recently, and with the US and Russia, and now with the commercial sector, also a US company with SpaceX going up and delivering people to the International Space Station. Yeah, this for me is like it becomes a new level of excitement to get to this. Oh, and just by the way, we've got Jim Cleland, from Scotland. He's dropped by to say hello. So g'day, Jim. Good to have you with us again.
Good to have you with us.
Yeah. All right. So I've just got a little thing here about the Ganganyaan mission. So what's actually will look like is they'll do some integrated airdrop tests. Then they're doing test vehicle missions, a pad abort test, and unmanned flights, and then the actual manned flight. So the human spaceflight mission, the test is supposed to happen before the end of 2023, with a second test the first quarter of 2024, with the actual flight in late next year. Ganganyaan project envisages a demonstration of human spaceflight capability by launching a crew of 3 members to an orbit of 400 kilometers for a 3-day mission, bringing them back safely to Earth, landing in the Indian Sea and their waters. The LVM-3 rocket will be reconfigured to meet human rating requirements and will become the human-rated LVM-3 or HLVM-3, and will be able to reach a low Earth orbit of around 400 kilometers. So yes, this is actually quite a significant change, and will be a massive, massive thing for them to do. Especially, I know they've been working on these things for such a long time. To end of next year is when they're going to do their human flight. That is just simply amazing to me. It's like they're all of a sudden India's hit their stride, and they're not holding back from this point onwards.
Oh, absolutely. I think you're going to start seeing an acceleration of the things they do. You think it's already accelerating, but it's going to go even faster for sure. Like, if you have interacted with folks in the Indian space industry, they're really building very impressive stuff all the time. So it looks really good.
Yeah, it's absolutely. It floors me. They've done parachute tests and all that sort of stuff as well. Like I don't have the images of that, unfortunately, but yeah, they've actually done the high using a rocket sled. They've used put the parachute out behind it just to make sure it'll actually go through the transfer of the high velocity from going suborbital velocity, so orbital velocity down to suborbital velocity, and then basically popping the chute, and it rolls out completely fine without a problem. It was a successful test, and it was a test that was done very, very early this year. So yeah, very interesting and very exciting time. So what do you reckon? What do you think that will do for the Australian space industry as a comparison? Do you think it will make us hurry up?
Look, we're definitely going to hurry up. It's a little embarrassing if you think about it. India's going so far ahead, but they're ahead of the race. I was just thinking along the lines of this is if you want an astronaut to do an experiment on the ISS for you, they charge $50,000 to $80,000 USD an hour.
Yep.
Right now, remember, look, it costs like $60 million or more to put an astronaut into space. They stay up for 3 months. So if you do the hours, it sort of makes sense, right?
Yep.
If India does this, at their cost differential, how cost effective would it be for us to go do more experiments in space? Instead of charging 80,000 an hour, do I spend then 15,000 an hour with an Indian astronaut to do the same mission?
Yeah, that comes down to a cost equation, doesn't it? And it's one of my favorite things to think about and entertain the notion of that is that what's the cost equation going to look like? And they've already $75 million to actually launch and get to the moon, and then the human space flight is their next port of call. Yes, what will it look like? What does that cost equation look like? What is the kilo to orbit? Cost per kilo to orbit from that point onwards, it's just going to be phenomenal, and it's going to get lower and lower and lower until, of course, Starship launches, and then they, providing it actually successfully gets to launch and doesn't destroy half the environment in the meantime. Sorry.
Right now, all Starship has to do is not blow up his own launch pad, right? That's basically it. But just to continue a bit on the cost equation front, those of us in the space industry know that we pay an arm and a leg to get anything into orbit. And, with Falcon 9 reusability, the cost of launching is less. So for us, for the longest time, and I'm saying since the birth of the space industry, we measure our cost by kilo, right? Because that's the biggest cost that we deal with. But when you look at what India is doing with sending an astronaut, there's a slight difference. There's a switch here. And that will be, we were going to be charging by the hour. And this is what I'm going to retain. So you go back to the first days on the internet in 1997, right? You don't pay by the meg, you pay by the time, right? Because you got a dial-up modem, you dial it on, and you pay by time to access. Because the time on the circuit to connect that phone line was cost more than the amount of data you could put through it. And when at some point we figured out how to get more data through the same pair of copper wires, and then we switched from charging time to charging by the megabyte. So we went to I want to use this for 2 hours. I go dial in, dial out, to I'll leave it on 24/7, and I just download my data. So what ISRO represents here is that very beginning of that transition for us in the space industry, that way we go from kilo or megabyte to time by hour. And that's actually quite a significant thing if you think about it, right? Because then suddenly I can go and says, how much is my mission? Oh, my mission is how much time I spend with the astronaut. I need 10 hours, 20 hours, versus I need to sit down, build my own hardware, launch it to space, do my experiment, manage to deorbit, collect the data from the ground station. It's a significant difference. So this is going to be a massive thing, right? Where we can then do experiments in space cheaply. So this is a really, really good thing that India is doing, and a lot of countries are going to follow suit.
Yeah, and the potential is just, sorry, yeah, okay, you've got me. That's got me. That's got me. Yeah, the potential of other countries that of similar ambitions, not necessarily ourselves, but ourselves as well. Yes, this is going to make it a very, very interesting use case for when everyone wants to go to the moon, and everybody wants to claim their stake, or get it to orbit, or to get to low Earth orbit, or to, yes, every single nation. This should inspire every single nation on Earth as well, not just like ourselves, but also the UK and Scotland. Yes, I'm looking at you, Jim. Yes, Jim, I can see you there, lurking around in the background. There's the UK Space Agency as well, that and they're looking to launch from Scotland as a number of different things as well. So yes, this will actually give a lot of credence towards other countries at least trying to get towards low Earth orbit, the moon and Mars, where the new space economy will be.
Yep. Actually, the question here then for you is, where do you think this economy is going to start? Well, we know low Earth orbit is already commercialized. So the next part is, will the Mars be commercialized first, or the moon be commercialized first?
Oh, good question. Okay, so I'll take it from 2 points of view. Because there are 2 points of view that in my head and they're conflicting, of course, just simply because of what I've been following. And one of the first one is the moon is a stepping stone to the rest of the solar system, just simply because it's our nearest celestial neighbor, and it's easy to get there and whatever else. However, landing on the moon presents a massive challenge in that it's got no atmosphere, and the regolith is abrasive and worse than coal dust, as an equivalent. And the moon may or may not have the necessary resources for us to survive, etc., 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 etc. And the moon is where most government agencies are aiming for, just simply because it's close. Now, the flip side to that is a very famous entrepreneur by the name of Elon Musk, SpaceX, and the need to get to Mars, or their company logo or company motto, I guess, is making the human species multiplanetary. With that, and he's hell bent on getting to Mars. Mind you, though, in order to get the successful government contracts, he's also won the Artemis mission. So I think it's Artemis 4, just from the top of my head, where he's landing astronauts on the moon. So I think he's covering all of his bases, but the end result will be to go to Mars. Again, also not great for humans, living in our little Goldilocks zone. We can't really get that anywhere else, as far as we know. We're finding more places, but pretty much we're the only ones for now. There is two sides to this. There's the commercial push and the governmental push. So, Brian, reflecting the question back on you, where do you think we'll get to first? And more importantly, why?
Okay, so as a space person, I'm going to take a special cop-out position. I'm going to say, I actually think,
chicken.
I think the place that will commercialize next is lunar orbit. Not the surface of the moon, but lunar orbit.
Yep.
Right?
Why?
We can park stuff there, low gravity, no atmosphere. We can use the moon-Earth orbit combination as a slingshot deeper into the solar system. So we're going to need like a place to refuel, recharge. Like even SpaceX Starship, if it's going to Mars, it's actually a 2-launch setup. First launch is the payload, and the second launch is a second batch of fuel so that it can actually take it to Mars. So right now we're doing that, but once we actually want to do it at scale, we want a gas station in orbit.
Oh, yeah. Absolutely, we want a gas station in orbit. Absolutely. Yeah. And that's already being proposed with the Lunar Gateway, which is Lockheed Martin. Pretty much name a few big. Sorry, I'll try that again. Name a few. I'm getting excited. I'm waving the microphone around. A few big of the big US aerospace companies have actually proposed that as something that will be a shuttle between Earth and Moon, and it will be continuously revolving around in translunar orbit continuously, and will never actually land. So. Yeah, okay. You make a solid point. You make a really solid point. Yes, all right. And by the way, we'll go to the Q&A now, because Jim has been making a few comments and all that sort of stuff while he's been there. So look, Jim has said that the Saxford. Sorry, I apologise, Jim, if I've gotten that wrong. You know what I'm like, mate. You've joined enough of these. I never get it right. Saxford Spaceport is looking pretty good at the moment and is looking like our best vertical launch option. Oh, okay. Once the UK government gets the grants license. Oh, well, once the UK government grants a license. Sorry, I said that the wrong way around. So, interesting. And yes, he also agrees with the Lunar Gateway. Yeah. So Jim, my question to you as the person who's interacting online, because I'm going to address you now directly. Why the Lunar Gateway? I will give you some time to think about that and to say why you think the Lunar Gateway is a good idea and a good option. We'll come back to that again in a minute, but I think now is probably a good time for us to move this item right along, because we could I could talk about our ability to become a multi-planetary species, and I have other thoughts as well, but I could talk about this long and forever, really. This would be a really long and boring stream, but all right. So I'll just come back a quick step for everybody. So I've noticed there's a few more people joining online as well. Just to let you know, we are giving away some I'm giving away some merchandise during this live stream. So if you have just joined, please remember that you need to participate. Ask a question, ask an interesting question, and towards the end, Brian and I will both decide which was the most interesting one, and you will get your selection of merchandise. I'm not going to limit you to anything. You can select your own merchandise in this particular instance. There is also these as well. There's the reset cups and mugs and all that sort of stuff, and there is also some other merchandise which I don't have, which is in a box over there. Yeah, it's in the box over there. I forgot to bring it close so I could pick it up and refer to it. So yeah, anyway, live. All right, so we're going to move right along to the sovereign launch capability here in Australia. So Equatorial Launch Australia has, or ELA, the owner and operator of Arnhem. Whoops. What have I done? All right, I'll try that again. Equatorial Launch Australia, the owner and operator of the Arnhem Space Centre, has signed a multi-year, multi-launch contract with a Korean aerospace company called INNOSPACE for a series of orbital launches. The agreement will see the launch of several InnoSpace rocket variants, each carrying between 50 and 500 kilo payloads into low Earth orbit from the ASC, that's the Arnhem Space Centre, across a 5-year time frame until December 2028. The InnoSpace offers 3 Handbeck class 2-stage rockets, including the Nano, which is a rocket payload capable of the 50 kilos, the Micro, a rocket with a payload capacity of 150 kilos, and the Mini is a 3-stage rocket, a little bit different from the other 2-stage rockets. It's a 3-stage rocket with a payload capacity of 500 kilos. The deal with ELA makes Australia the 3rd location for InnoSpace, which they'll be launching from. Other locations currently include the Alcantara Space Centre, and that's in Brazil, and the Andøya Space Centre in Norway. So yes, that's a very new and interesting one. And here is the announcement from ELA's own CEO.
Hi, I'm Michael Jones. I'm the Executive Chairman and Chief Executive of Equatorial Launch Australia. And today we're announcing a very exciting event in our history. We're announcing that we have signed a multi-year, multi-launch deal with INNOSPACE, company from Korea, who has already successfully launched a hybrid fuel rocket into space, the first hybrid fuel rocket that has actually reached space. It's a very exciting announcement from our perspective and really has gone a long way to validating both our business plan and our method of operations into the future. We believe that this announcement today, which includes the establishment of a workforce of InnoSpace in Australia at their Space Launch Complex at the Arnhem Space Centre in the Northern Territory. But it also moves forward for us in the perspective of being able to now prove to other customers the concept of what we're offering and for us to move forward. This launch and the announcement that we've made is also very rewarding for all our staff who behind the scenes have been working on the next stages of development, the technology and the design, the licensing and all the regulatory aspects that go with operating a complex space launch aspect. The activities that we undertake and those of our customers are really challenging, both from a perspective of technology, but also making the financials and the commercial aspects of it work. So we're very encouraged by this announcement, and we expect to make quite a few more by the end of this calendar year.
Yep. Absolutely great to hear that. Like, I mean, a lot of people, one reason why a lot of people ask me is like, why do you want to launch from Australia? And I will say that I got this one wrong for the longest time. I would tell them all the correct things. And I would say the right orbital dynamics. You got these orbits which are really valuable, et cetera, and you got like all this positioning awareness for especially sun synchronous orbit, which everybody likes. And then the guy pulled me aside and goes, no, all of that's cool, but that's not the point. And we were like, what? And he goes, well, you can launch anytime. If I want to launch out of Europe, I want to launch out of Japan, I want to launch out of USA, there are planes in the air. They get stupidly annoyed when you have a rocket to launch because they divert the planes. But in Australia, 80%, 89% of our country is empty. You can launch every day, non-stop. And the only thing you're going to hit is air.
Yeah, that is true, mate. That's absolutely true. Yeah, it's when you look at it from, so I've done a little bit of work in a previous life in regard to this sort of stuff, and yes, the looking at the airspace above Australia as compared to the United States or Europe or even Asian nations in that fact, yes, absolutely, we are a lot better place just simply because look, so I was doing something to do with drones, and yes, I was looking at coming into somewhere around Brisbane City, and Brisbane City's I didn't think Brisbane City was that busy until I looked at the maps and the air routes and all that sort of stuff. So yes, once I looked at that, and then I had a conversation with someone who was actually very experienced in the industry, and they said, you're not going to be flying into Brisbane with a drone because you're going to be upsetting all of our national carriers, Virgin Australia, Qantas, and Qatar, and anyone else who's coming in, and it's going to cost them hundreds of thousands of dollars for them to divert themselves just for you to get out of the way for you to land some drones. He used a few more interesting words other than that, but just for you to use some words. Yeah, but he's just gone, you can't do that. And he said, pick anywhere else in the middle somewhere. There is relatively nothing. The only thing you need to be concerned about in Australia, in this country, is if you land on something, there might be some infrastructure or something on the ground which you're unaware of that you might actually land on top of. And that's where you need to, when you're looking to deorbit something, you either deorbit into, as we all know, the ocean. But if you're going to be launching, you need to then launch it. If your rocket blows up, you need to look at the spread of the debris, and where the debris spread will go is whether or not that'll impact any ground-based infrastructure, and that's apparently a really big one as well. So yes, very, very interesting, but much clearer than other countries, much clearer, with not much competition either for fighting for airspace or someone who might launch a rocket and think it's something else.
Absolutely. Well, the other half is that's a good point. If you launch out of Australia, no country's going to assume you're going under attack. You know, because we're going to launch eastward over the ocean, right? So, and like the only thing we're likely to hit is New Zealand.
Sorry to all the Kiwis out there. Oh, look, hopefully you'd be high enough and further and far enough along towards it actually being in an orbital track before you'd even hit New Zealand.
Exactly. Look. I say it. I want to be clear. I say it in jest.
Yes,
right. Like the likelihood of hitting New Zealand is very bad. It's more for our viewers out there to know that I'm just totally kidding. I love my Kiwis, right? I love their sheep. I love their people. But if I'm going to hit anybody, right, it's not going to be Kiwis. I want to be clear about that, right?
Yeah. No. Look. It's for anyone who's watching overseas, Australia and New Zealand, we have this international rivalry where we're part of the Anzacs, so the Australian New Zealand Army Corps. We actually fought together in World War II, all that sort of stuff. So yeah, we're brothers in arms, and then basically we've been taking the mickey out of each other since that moment. When war calls, yes, we all get together and we're brothers in arms, but every other time we just torment each other. They make jokes about us and they're not great, and we make jokes about them and they're rude.
Absolutely. This is like the jokes that you only have between your family members. You don't tell anyone in the public.
Yeah, correct. That is entirely true. That is entirely true.
Absolutely. So usually that kind of joke is reserved between the Australians and the Kiwis. We don't do it on live stream and tell everybody that kind of thing.
Oh, don't we? Oh, oops.
Oh, really? I didn't realize that.
This is live. Oh my god! I thought we were just chatting.
Yeah,
Oh, all right. All right. Let's have a look. We've got a bit of a feedback from Jim here, so I'll just call that up. So, what has Jim said? Jim has said now it's blurred. Oh, there we go. All right. The journey to various planets, moons, etc., is a marathon. Definitely not a sprint. Yeah, true. We'll almost certainly need pit stops along the way. Yeah, that's also true. The original lunar mission concept relied on this, but the politics got in the way. Absolutely, without a doubt, yes, and that's in response to the orbital gate, the lunar gateway. So yes, good pick up there, Jim. And Brian has a great point about the airspace over Australia. The launch facility at Saxford is most extreme north of Scotland. The aircraft are limited in this area, so well, that's if you discount Russian recon.
Look, I get to say this at this point and goes, if you by accident hit Russian recon, I don't think anyone is really going to care. In fact, you might actually get a celebration.
That is entirely true. That is entirely true. I just realized you couldn't read everything on the screen there, so there we go. All right. Yes. Anyway, let's move rapidly away from that.
All right. Yeah.
As much as we can. Oh, look. All due respect, I'm just going to pay quick 20 seconds homage. The Russians have actually done a lot in terms of space and space development and technology. It's just unfortunate that there's not such an emphasis on the Roscosmos anymore, which is really, really unfortunate. So yes, there's my. Do you think that'll work?
Yeah, that will work.
All right, moving right along. Basically, Gilmour Space Technologies has shared some behind the scenes about the Bowen Orbital Launch Facility, and they released this image just the other day. The Bowen Orbital Launch Spaceport is in North Queensland. Pictured on this here, this is a very rare behind-the-scenes look, is the launch pad with the fluids tower. At the moment, they are still pushing towards Launch Australia's first sovereign-made orbital launch vehicle this year, no later than December 2023. So yes, interesting. Very interesting photo. Very interesting. Do you think? What are your thoughts? Rather than going, do you think? I'll go. What are your thoughts about this, Brian?
Yeah. Look, good luck to them. Like building launch is always hard. You know, look. There's a saying in project planning. Everything takes 3 times the cost and 3 times longer.
Yes.
So credit to them for even pushing through and making it last that long. You know, it's hard work, right? So even if they don't make the cut, credit for pushing to that target. If they don't launch, even credit for trying. Like seriously. And as a joke with friends, the only thing you guarantee is a fireworks display.
Yes, absolutely. I mean, and that's the thing. The whole idea is to fail fast and fail forward, to use someone else's analogy, but also at the same time, whatever they do, it's going to be an achievement for the Australian Australian space industry, regardless. And you know, I will certainly be not one to say that it's a bad thing. I'll be the person who'll be saying, yeah, well, they did a fantastic job and well done for getting as far as what they did, and because the whole country's aspirations not ride on your shoulders, but it just inspires so many more people. Once you do successfully make it to orbit, or even try to make it to orbit, it's just going to the whole country will just be. It'll be a moment, whether it fails or is completely successful. It's just going to be a moment where we'll all just be watching on the edge of our seats, hoping for the best. But the underdog, and we'll get something up there, and it will launch successfully. So yes, very, 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 very cool that they're actually going to be doing that.
Yeah, very
all right.
Cool.
Hey.
All right. The next one, I shall say.
Next one, we're going to go to some news. Okay, the next lot of news is Spiral Blue's Edge Computing SE-1 has been working hard in low Earth orbit on board a Satellogic satellite to test machine learning applications, including cloud detect, vessel detect, and water body mapping. Next up is Spin Launch. Spin Launch is conducting a feasibility study to determine if two areas of Crown Land off the Air Highway in WA could be used as a launch site for its orbital accelerator. Several sites around the world are currently under consideration, including two on the south coast of Western Australia near Mundrabilla, 800 kilometres from Kalgoorlie, and 1,300 kilometres from Perth. Spin Launch uses a slingshot where it accelerates the rocket up to 8,000 kilometers per hour, or roughly 5,000 miles per hour, before release. During the spin sequence, the payload can experience forces of up to 20,000 Gs. I knew I'd get that wrong. Or 20,000 times of the gravity of what we feel now. Oh dear, this is what happens when you hit the wrong button. Accidentally hit the wrong button. That wasn't complete, but yeah, that is absolutely insane. Yeah. That's an interesting way to get to orbit, mate. I really think that's wow. That's incredible.
Yeah, totally.
What do you reckon? What do you reckon? What are your thoughts?
Oh man, look, I think anyone in this, we all know that like the hardest part is like the first 10% of the atmosphere, right? Because that's the first 10% of the altitude is like 90% of the atmosphere, and anything to reduce that is amazingly hard, right? So the fact that Spin Launch has a way that even theoretically, let's say theoretically, like actually works at a scale model down approach is absolutely stunning, because it's like SpaceX rocket could shrink by a good 50% on the spot if they were launching on a similar method.
Yep.
How much smaller it is, that is an engineering question, right? But like from a fuel consumption standpoint, 90% of the effort is in the first few minutes of flight, because you're getting to the atmosphere. In fact, you have to go slow in order to actually not get destroyed on the way up.
Yeah, correct, which is actually why they declare max Q, when you pass through the maximum amount of aerodynamic pressure on the vehicle as you're accelerating up through the atmosphere. Despite the fact that it keeps getting thinner and thinner, you're going faster and faster and faster. And yeah, and the other thing is too is we live at the bottom of a gravity well, and it's a pretty strong one too, but not as strong as Jupiter or anything like that. Yes, let's not go nuts. But yeah, that's exactly why SpaceX returns the first stage of all their rockets, is just simply because that's where the workhorse is. It gets the second stage to orbit by passing through the thicker parts of the atmosphere. And on return, even if you just watch a SpaceX launch on return and you see the speed on the left-hand side, traditionally is what it's on, the speed as it gets closer to the ground, after they do their orbital burn at the top of the orbital burn, so that way they wash off a lot of that speed, the rest of that speed actually drops quite considerably before their last burn, by a few thousand kilometers per hour, just by passing through into the thicker parts of the atmosphere. It's just insane. So yes, it seems like it's really, really weird, but yeah, for Spin Launch to do that at 20,000 Gs, or and it still survives, yes, this will be interesting to see. Oh, yes, of course, you can come to Australia and interview with me. Join me on a live stream. I promise I'll get better at some point. No, I've been doing these a while now. I don't get better. It just gets more interesting every single time. So yeah. So yes, you Spin Launch, you're more than welcome to come and have a chat with me, Josh Keegan, the Space Down Under. I think I've done myself enough reputational damage now online. I've managed to insult a few people and talk about the Australia-New Zealand relationship that we shouldn't talk about online. So.
Oh man, if we need, we can go far deeper, right? Like I was just being polite about it.
Oh,
still.
I know those. Anyway, yes, we will get into that another time. And we'll probably won't actually live stream it when we do it either. Probably not the best idea to be doing this and transmitting it to the entire world. But anyway, that's right. That's a different story. All right. Coming back to the space news, we're just going to it's not Australian space news. We're just going to cast our net a little bit further afar. So, unfortunately, speaking of the moon and the moon orientation that we've been on today, Luna 25 actually crashed into the moon. It was unsuccessful, and it was just only days before the ISRO and the Chandrayaan-3 actually successfully landed on the moon. Russia has declared that the race to explore and develop the moon's resources has definitely begun. Despite the failure of Luna 25 on August 19, Russia's first lunar mission in 47 years, the head of Roscosmos, Yuri Brosnov, said that they must remain a player. The reason for the crash? A maneuvering engine could not be shut down, and it ran for 127 seconds instead of 84. That makes things a bit interesting. And yes, and it really proves exactly how successful ISRO was with their Chandrayaan-3 mission landing successfully on the moon. I mean, that's what happens when you go to try and land. Things just, the best laid plans and intentions and testing may, in the end, may not work.
Yeah, like I credit this stuff is still hard, right? Like, do not assume any of this is routine. A lot of this is the engineer's equivalent of crossing your fingers and praying to God.
Yeah, or whatever God you actually pray to, because I know that India has quite a few. So sorry, I'm not casting dispersions or anything like that, but yes, look, I'd rather err on the side of cultural correct, just because and it worked. Everyone prayed, like a billion Indians, and Vishnu or whoever it is, or the goddess of luck and good fortune, smiled upon them that day, and they landed. In comparison with Russia, who just only a few days beforehand, failure, overburned 127 seconds, and we all saw the results. Moving right along. So moving to China's Chang'e 4, which landed on the far side of the moon in 2018, has been sampling minerals from the moon's mantle. From these samples, scientists are able to visualize the layer cake of structures that comprise the upper 300 meters of the moon's surface in a finer detail than has ever been done before. Chang'e 4's rover Yutu-2 is equipped with technology called Lunar Penetrating Radar, or LPR, which enables the rover to send radio signals deep into the moon's surface. The picture built up has revealed 5 distinct layers of the lunar lava that seeped across the landscape billions of years ago. So yes, very, very interesting, that one, that it's still operating, it's still successful, and it's still on the far side of the moon, creating new giving us new scientific information all the time. So, yeah.
It's also to see that lunar penetrating radar. I wonder actually what that actually is from like a technical perspective, right?
I don't know. That's all I could find. Lunar penetrating radar. I'm like, well, what does that mean? There's probably some documents there somewhere. But yes, very, very interesting that, that it's still, look, 2018 it landed. It's still going.
Yeah, that's impressive.
Yeah, really impressive. And it's on the far side of the moon too. So it's almost, it's perpetually in dark. So yes, very interesting to know what is keeping that particular craft warm. All right, we're going to switch to the questions and answers because Jim has been going a little bit nuts.
Yeah, Jim,
literally, good participation there, Jim. So thanks very much for participating actively participating during this live stream, so appreciate that. So if anybody else wants to participate, remember there is some potential free merchandise on offer. All right, Gilmour looks terrific and looks forward to seeing and hearing more. Some people will moan about what's taking different companies so long to achieve what the US and Russia have already done. Yeah, okay, good point. But come on, people, it really is rocket science. Yes, good point, mate. Absolutely good point. It's difficult and dangerous, and private companies do not have the multi-million-dollar budgets of national agencies. Success to every private agency. All right. Yeah, absolutely, mate. I 100% agree. And what is it? The principle of planetary slingshot is pretty well known, but why is it taking so long for the spin launch idea to happen on Earth? It seems an incredible idea. Yeah. 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 Good question. Hey, Brian, you got any ideas?
Yeah,
There we go. I'm going to pose that one to you. Why haven't we tried something like spin launch before?
So everyone knows, spinning is a good way of getting something up fast. A couple of interesting things about that. First, the rocket goes in a vacuum chamber.
Yep.
If you look at it honestly, it's one of the largest vacuum chambers we're working with here, just in volume. And you think about how much pressure to move. Those vacuum pumps are really new tech, right?
Gotcha.
Just the vacuum pump alone, that's the first thing, right?
Yep.
The second thing I want to mention is that thing is electrically driven. That's not like your drone motor, that's spinning there, right? Generally speaking, the really, really high-powered RPMs motor systems are actually all chemical, like it's a diesel piston engine or something like that.
Yep.
But I think the thing that's not being shown, I think, is that it has to probably be a custom AC or DC motor that is creating the spin, right? Because you think about how the velocity requirements, and then you got to think about the amount of torque that thing's going to put on it.
Yeah.
Those are really, really hard. That's a really hard piece of work you got to do. And it's of course not being shown. The third, they're using a lot of carbon fiber for the arm, for the spin, and for the craft. Large-scale carbon fiber manufacturing like that is really hard by any standard, even by today.
Yeah.
If you ever make anything that big, you got to layer up the carbon fiber, put the coating and everything, and you got to put it in a vacuum chamber that's big enough for the whole thing. So those things are massive. So all that stuff is actually very new tech that you couldn't have done before. And I think most of that thing has only really come into existence in the last 15 years.
Yeah, no, I agree. I agree. I was just taking in, remembering to breathe. Yeah, so yeah, absolutely agreed that that is all reasonably recent tech. Yes, and because when you think about spinning something up to 20,000 RPM or sorry, it's not 20,000 RPM, but 20,000 Gs potential when it's at full maximum power, and then the electrical motor to actually get it up to that. Yes, whilst it's common for us to do that in other applications, this is the first time it's being done inside a vacuum chamber, which you make a really good point. And the vacuum chamber is that large. Apart from NASA having one at Stennis, I think it's Stennis Island, is where they have theirs. Yeah, that vacuum chambers or pumps they're able to evacuate a vacuum chamber like that. Yes, apart from it, NASA has it, and I'm not sure if it'd be proprietary, but yeah, actually releasing that information to private industry and then building your own.
Yeah. Mm-hmm. Yeah, it probably is the largest private industry one I've seen, right? I mean, in fairness, there's probably bigger ones for like the shipbuilding industry, but for the level of vacuum they're after, probably not true to sit there. And the other half of it that I haven't figured out is the seal. You got that thing spinning, there's motors equipment running through. How do you maintain that freaking pressure seal in that kind of vacuum?
Yeah.
Like I'm like still thinking like, okay, this is not a straightforward answer anymore.
Yes. No, like I'm sitting here listening to you and I'm trying to think it through and I'm like, no, I haven't seen anything like that before. This is new. This is completely new. Yeah, absolutely. And yeah, fantastic explanation, Brian. Thank you very much for that. I appreciate it. Yeah, that actually prompted me to remember that, yes, this is very new tech. Very, very new tech. All right, going to our last space story. It turns out that Momentous, so someone at least is not doing quite so well. Momentous in the US has recently cut its workplace by as much as 30%. The cash cash-strapped company seeks to reduce its costs while looking for strategic options to raise funds. The CFO, Eric Williams, has been quoted as saying that the move was designed to substantially reduce our burn rate while retaining talent we need to execute our key near-term initiatives. So, is this foreshadowing something that is going to happen soon, do you think? Or do you think it's just a one-off? Because I've heard other things out and about and all that sort of stuff in terms of international players. The last one I saw was Blue Origin has also gone through a similar thing where they've gotten rid of around about 30% of their staff. Most businesses have gotten rid of around about 30% of their staff, Microsoft and Google and whoever else, and they're techs, but techs always get rid of staff. That's something they do. Is this something not new, but is this something that's a new trend? Well, a new trend for the space industry.
As far as I'm concerned, what moment you just read, that's the PR speak of we screwed up. And we need to be polite about it. We need to make it sound like we're doing smart things about it. But if you cut 30% of your workforce, now, if the 30% are the newcomers in the business, all right, I believe you're cleaning out. You're just like cleaning and making it more efficient. But if that 30% includes senior staff, who have deep technical and tacit knowledge about the business that you cannot acquire from a hire, something's wrong. You absolutely know something is wrong. So I don't know what's going on internally beyond the press release. Like you have heard things around the trappings. And, if you were launching with them, you would be concerned. And I think rightfully you should be. And as far as I hope Momentus cleans up and makes itself work, but do also note their share price tanked quite significantly when they made the announcement.
Yeah, I saw that. I didn't want to say it, but yes, their share price. I know Momentus has done a few different things in terms of launch, and there's been a few Australian companies that have tried to use Momentus to actually get their payload to orbit. This is going to make things very, very interesting and fascinating in the next few months, possibly years.
Absolutely.
Yeah. It's concerning. And look, you highlighted the Momentus article through the week, and then not more than 24 hours later, maybe even 12 hours later, I saw the posts coming out about Blue Origin, how they've suddenly sacked 30% of their staff, and I was like, hang on, they're billionaire backed. They can go as long as they like, because they don't have to go out to industry or to venture capitalists or anything like that to go and get funds. Like, it's for me, Blue Origin at Momentus. Yes, okay, I understand. Blue Origin is another one. It's like, hang on, that doesn't make any sense. Just because Jeff Bezos and Amazon is supporting the development of the rockets, for me, that just feels like something has gone wrong, and they just haven't admitted it publicly. And does that mean that the Blue Origin rocket is never going to launch? Because they've talked about that for years, and there's been nothing yet. And also the New Glenn rocket, that's had problems. This could just simply be the falling out from the New Glenn having problems, and that's the tourist rocket that does the suborbital trips. But it's just weird for me. I can't quite compute how a billionaire-backed company, whose staff would theoretically be safe, be getting rid of people. That's the bit I don't get.
Well, first, Blue Origin survived because Jeff Bezos sells Amazon shares to keep it going.
Yeah, correct.
So fluctuation on Amazon shares. This is the first thing, right? It lost a lot of its valuation recently, and this is probably part of the process playing out. Second, Jeff Bezos actually returned to CEO of Amazon, if I recall correctly, versus being Blue Origin. Yeah, and when you change the CEO, he's going to change it up. So it's probably like under Jeff Bezos' watch, it's like, let's go aggressive, let's go quick. Did a massive hiring spree to go on because we can afford it. And then the share price tanks. Jeff Bezos has to return. Those are two very, very big hits that they're on, right? So they're like, okay, let's lean this out. Let's figure this out. And that's for their rocket. We don't know. because they haven't launched anything really. They talk a lot about it, but they haven't launched it. Like, I know there are really good people there, and you can hear stories of them working really, really hard. And there's some concerns and other things you can talk about, but they haven't shown anything. They show more renders than they show technical of any kind.
Yeah, true. I mean, I've seen some behind the scenes hardware, and it's just been in pieces, and nothing's being joined together, and all that sort of stuff. And they've got the supply of the BE4 engine to ULA, so United Launch Alliance. They're supplying them with their engines for their next rocket. I can't remember what it's called at this point. Atlas was the old one. Anyway. So yeah, they've got that squared away, and I do know they had a few problems with getting those qualified as well, because ULA was reaching out to Blue Origin and saying, what have you done with the engines? Because but they were working through those issues. So it wasn't massive, but it was more or less private until people talked about it. So very interesting that I didn't think about the share price tanking, and so he would have Jeff would have gone straight back across to Amazon just to make sure that was going okay and left someone else in charge, which means that as rightly so, they would have cleared house. Absolutely agree. All right, cool. All right, well, let's get to our Q&A. Our wonderful Q&A, which just seems to be us and Jim and not much else. There are a few people watching though, so hi to everyone who's watching. We're about to have a look at the draw. So and it seems like we'll give people a few seconds to respond if they wish. If you want to ask us an interesting question, please feel free to do so. This is not a three-way conversation between myself, Brian, and Jim. Who's watching all the way from Scotland, so g'day, mate. So this is your chance to actually win some pretty cool Space Down Under merchandise. I've got a cooler here, and yes, while one of the videos was playing, I went and reached for some of the merchandise, and also your very own Space Down Under vest. So if you want to go and attend a rocket launch and you want to make sure that you're visible, you get your own very own high vis vest. If you can also select that as a potential prize as well. There is a lot more on the space shop.thespacedownunder.com if you want to go and have a look. Look through all of that and just let me know. So what I'll do is I'll reach out afterwards and I'll just say, look, you can select what you'd like. It doesn't seem like anyone else is participating, so that's all right. Congratulations, Jim. Mate, I'll be in contact soon to ask you what you want. I already got all your details, so that's not too hard. Here we go. We've got a question, and it's from Jim, of course.
Cool.
If you had the chance to travel in space, LEO, would you take it? Oh, that's a good one. I've been asked this one before. He does this to me a lot. I've answered this one, so I'm going to give Brian, I'm going to give you a chance.
All right. Really simple answer is I am not interested in a roller coaster ride, but if I'm going, I'm going.
Yep, fair enough.
Like where's my hotel? Where's my freaking space station, right? I'm the guy who wants to figure out how to build a space station orbiting the Earth and send it to Jupiter, right? I'm not the guy who wants to talk about Mars and the Moon. So I would go to Leo. I would definitely do it if there was a space station. I would love to be spending time in a giant O'Neill cylinder.
Oh yes.
Have you like how amazing it would be to be up there, just traveling through space, and you're like just sitting on your pina coladas by the beach.
I agree. And also, an interesting question for you, Jim. Now I'm going to throw it back at you. Would you go? I know you got to type a response, mate, so get cracking. So yes, Jim, would you actually go to, if you had a chance to travel in space to Earth, or but Moon, Mars, whatever it is, would you actually go yourself, mate? And while you're talking about that, I will just give you my response, which everyone has heard of before, which is yes, without doubt. Again, like Brian, I probably wouldn't go for the roller coaster ride. However, just I would go just because of the experience, even if it was a roller coaster ride, just to go up and come back. I would like to do more than just go up and come back, and just be out of my seat for 30 seconds to a minute, aka Virgin Galactic or Blue Origin on their New Glenn. No, I'd prefer to go around a few times, pretty much like the like the 4 who traveled on the Dragon capsule. That me, yeah, I prefer to do something like that. Yes, it would be crammed, and yes, it would be not great, but yeah, I would still do it. I would do it in a heartbeat. Absolutely, I would scare this. Don't get me wrong, it would scare the living daylights out of me. I probably wouldn't sleep. But yes, I would still go, because yes, it would be an amazing and magnificent experience. And let's just see. Great answer. Space station rather than spam in a can.
Yeah. I gotta admit, I like the term spam in a can.
Yeah, I know. And he's also said in a heartbeat. Absolutely, I appreciate that, mate. Yeah, I get that entirely. All right. Well, thank you very much, Brian. It has been an absolute pleasure joining me again for Igniting the Space Down Under for September. So September 23. So September of 2023. Look, if you want any more information about Brian, I've obviously placed links in the description below, so you can go down there and find out more about Brian and what Brian does. And and you can also find the interview with myself and Brian in regard to Dandelions and his orbital space ambitions for that particular device. The gyro shoot, was that what it was called? Gyro shoot?
Yeah, the gyro shoot.
Gyro shoot. See, I do have a good memory occasionally.
Okay.
I appreciate again, mate. I appreciate your time for joining me again this month, and hopefully we'll have some more stuff next month. So if you manage to like this live stream, if you know what to do, you got to like, subscribe, do all that funny stuff, and next time we might have a live stream. You could possibly also have the chance of winning some merchandise. So guys, again, thanks very much for watching Igniting the Space Down Under, and always remember, stay caffeinated.